With that long introduction, I'm going to add just a couple of things. First of all, I'm not a caribou biologist, and I think you've already figured out I'm not a Canadian. So I feel like I'm pretty lucky to be here. My background is research on nutritional ecology of large ungulates in general. For the most part of my career, this has been the topic of my investigations, working primarily on elk and a little bit of bighorn sheep. A hallmark of that work is the integration of data collected from tame animals with that collected from wild animals. It's been a very profitable and synergistic kind of approach to doing wildlife research. That's all the introduction I guess I have time for, but I would like to mention that we are starting a new research project that capitalizes on that integration of tame animal and wild animal work that will start here in BC in the near future. I'd like to introduce the compatriots on this talk and future research. Rachel Cook with Julianne there in the bottom left. Julianne is a 22-year-old elk that we're still using for research. Kathy Parker is the academic leader on some of this upcoming work, and we're looking for 2 PhD students right now. She would be the person to talk to. Lynn Brown from Ontario and Darren Sleep from Nacassie as well. What I'm going to talk about today is summer nutrition, the importance of summer nutrition. I'd like to start with a little bit of background. The prevailing perception about the importance of summer nutrition in my profession since its inception is that it's really not an issue. The world is green, vegetation is growing, so what's the problem? The problem is that the perception didn't account for the inordinately high requirements for lactation, juvenile growth, and accretion of energy reserves in preparation for winter. The assumption has always been, for at least 75 years, that green world out there adequately, or more than adequately, satisfied those nutritional needs. But particularly in the early days, not once was this assumption ever tested with good, rigorous science. In more recent years, there are tests of this assumption, and the evidence is growing, refuting the hypothesis of a summer nutritional utopia. In some ecological settings for deer, elk, and other species, this summer nutritional utopia just ain't so. Some of the best evidence of summer nutrition effects comes from caribou studies in North America, although I would have to admit that that's from mountain and barren ground caribou work. I'm going to talk a little bit about elk nutrition just for a second to lay kind of a conceptual groundwork and then get into a series of caribou studies and blast through those real quickly. Based on 17 years of elk work, what we have found is that we can get these kind of three patterns in terms of summer nutrition effects on body fat. Elk come out of the winter with 3 to 5% body fat typically. Some herds less, some herds more. In a low nutrition environment in the summertime, these animals are barely able to put on any fat at all as summer progresses, such that they exit the summer range with anywhere from 5 to 6% body fat. About 30% of the herds of 25 elk herds we've sampled fall into this category. About 50% of the elk herds that we sampled fall into this medium category, where they put on a little bit more body fat, but come off the summer range with 7 to 8 percentage points of body fat. We have encountered 2 herds out of those 25 that fall into this high category with 13, 14, 15% body fat. One of those herds, by the way, resides on the north side of Mount Rainier, for those of you who may be familiar with that. Well, these 3 nutritional regimes have big implications in terms of animal performance. At that low level of nutrition, virtually any reproduction variable or animal performance variable that you can think of is highly significantly reduced by this low nutrition level. At the medium nutrition level, most of these variables are also influenced, with one exception that's very important to note: pregnancy rates. Pregnancy rates are resilient to low nutrition, and the upshot is that pregnancy rates thus are a poor indicator of nutritional status of a herd unless nutrition is really, really poor. The point I would make about high summer nutrition is that what we found with elk, if they, no matter how low a condition they come out of winter, virtually no body fat at all, if summer nutrition is really as good as many people believe, then these animals have no problem raising a calf and ending the summer with very high levels of body fat. They can do it. A caveat before I jump into the caribou literature. Karen Gerhardt pointed this out with caribou back in the mid-90s with work in northern Alaska. If a female loses her calf early in the summer, she will, in the summer, with very nice levels of body fat and a high probability of getting pregnant, no matter how poor the summer nutritional regime is for lactating females. The upshot, the implication is this: if we go out and measure body fat or pregnancy from caribou, and we find that they're fat, but we cannot take into account their lactation status from the previous summer, then we're very likely measuring body fat and pregnancy of animals that have not raised a calf, and thus inferences from that data can be, and very, very often are, entirely misleading. One has to be very careful with these kind of data because of confounding by lactation status. Well, the first question that comes up are these patterns that we've seen with elk, do these patterns exist in the caribou world? There are 3 publications that I'm aware of that show body fat levels in the annual cycle for caribou in North America. The first is from the George River herd, and what this data shows is this very low level of summer body fat that indicates very poor summer nutrition. The second is the polar opposite, data collected in the Coast Island herd back in the 80s as well. These animals showed a remarkable ability to put on body fat during the summertime. The third data set is from northern Alaska, and it kind of falls pretty close to this low end of summer nutrition. So the patterns that we see in elk are well represented in the caribou literature. Eric Post and David Klein back in the late 90s published a study where they compared habitat conditions, predator populations for 2 adjacent caribou herds in southwest Alaska. One of the herds had very high calf-cow ratios in July, the other had low. At the end of this, they determined that summer was driving that boat. Bruce Dale and Lane Adams, in a long series of studies, showed complicated interactions of summer nutrition and winter and spring weather and reproduction performance. In a 2008 paper, I would encourage you to take a look at, in terms of juvenile growth across the annual cycle, they found that winter nutrition had no lasting effects on body size and growth, whereas summer nutrition determined and limited growth rates in that region. Beginning way back in the early 1980s, work that Bob White did, followed up by Raymond Cameron, Karen Gerhardt, and Don Russell, and other folks, they have found over all those years of studies that summer nutrition delayed timing of breeding, reduced pregnancy rates, and interacted with winter-spring weather to affect neonatal calf viability and survival. In unfinished work in a PhD dissertation, Liv Vors has analyzed data collected back in the 80s on fetal weight of caribou calves in March. They found that indices of out-of-body fat, late summer NDVI indices, significantly influenced fetal size in March, whereas winter snow depth and precipitation had no significant relationship. Back to the George River herd, this is probably the classic summer nutrition study that's been done for caribou. They reported that inadequate summer nutrition had large effects on body fat of adults, growth of juveniles, pregnancy rates, reproductive success, and survival. In a summary article, or a summary table presented by Lane Adams and Bruce Dale in 1998 in JWM, they presented a summary or a review of all of the major studies that had pregnancy rate data. And they broke it out by age class. The first column is for very young animals. And I would back up and note that in a recent paper on woodland caribou, it's been noted that yearlings are perfectly capable of maintaining very high pregnancy rates if nutrition is high. What these data indicate is a very serious problem with yearlings being able to breed in the wild. A year older gets a little better, but still strong impediments to successful breeding. And even in prime age animals, of these 14 herds, only 3 of these herds were able to achieve pregnancy rates in excess of 90%. New data that have been collected mainly by Rachel and myself in Ontario and a little bit in British Columbia. This is in the heart of the woodland caribou range for a change. In 2009 and 2010, working with Glenn Brown and other folks in Ontario, we were able to get our hands on 194 adult females in 9 herds. Just a little bit of background, 5 were 10 years old or older, 2 were calves and 8 were yearlings. And before I forget, I would point out that the yearling pregnancy rate there was 38%, sorry. In 2012, this past winter, we got our hands on 21 caribou and 2 herds in British Columbia. Excuse me. We measured using ultrasound rump fat thickness, and we've used a preliminary equation developed by Tom Stevenson in Alaska to convert estimates of rump fat thickness over to ingest-free body fat. This is all preliminary stuff, so the estimates of body fat, keep in mind, are probably going to be refined. These are the herd level body fat estimates for all the data that we've collected so far. The thing that jumps out at first glance is dramatically different levels of body fat among herds. Some are high, some are low. But what we found with elk is often it's better or more instructive to look at these data sets from the perspective of a frequency histogram instead of herd means. We put a box around these, and the first thing that jumps out is, gosh, there's a whole lot of fat caribou running around Ontario. But the problem is, if you think back to what I said about pregnancy, these data were collected in February and March. And we don't know if these animals are fat because they had good summer nutrition or simply because they lost their calf early in the summer. And for that reason, it's probably more instructive to look at this side of the graphs. With elk, you could just about be sure that these thin animals were the ones that actually raised their calf. What we see here is 1/3 to 1/2 of these animals at 6% body fat or less in 3 of the herds. Pregnancy rates, 4 herds out of this data set were very high. 4 herds showed at least moderate levels of reduction in pregnancy. The ones that didn't breed were the skinny ones. I wanted to get the implications, but I'm not going to get there. I'm out of time. But I think what these data indicate so far, from a North American perspective, is that the preponderance of caribou data generally rejects the hypothesis of this summer nutritional utopia. One thing that is absolutely for sure, the magnitude of limitations vary substantially among populations. No one size fits all. If we do one study in Manitoba and we find fat animals, we better be careful applying those results very far down the road. Of course, the $100 question is, woodland caribou in Canada an exception? Are they really an exception? Well, you probably can guess what my opinion is, but I'll let you answer that question. The final point that I would like to make before I stop here is that we are, in fact, making no claim at all that inadequate summer nutrition is causing widespread declines in woodland caribou.